I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Pledge of respect. I am a smart, special, valuable person. I respect myself and I respect others. My words and actions are kind and honest. I accept only my best in all I do. I am proud to be me.
Good morning. Today is Tuesday, January 13th. There are no birthdays to celebrate today. There's Connect Club today, and the saint of the week is Saint Anthony of Egypt. Have a grace day.
Hey, I'm just making a planet. Well, this is how planets like Earth get their structure anyway, because of different layers of density. Even today, with all of our modern technology, we've only been able to drill about a third of the way through Earth's crust. So how do we really know if it's solid, liquid, hollow? Luckily, Earth has this tendency to violently shake and occasionally burp up some of its insides. And that's taught us a lot about our planet's guts without having to go down there. We're used to seeing density at work. That's the same reason that the atmosphere, the least dense part of our planet, is on the outside. And the crust, the second least dense part of the Earth, is beneath our feet. Because I'm less dense than the dirt, I don't sink into the ground. And even though there's about 1 ton of atmosphere above my head, it's not dense enough to send me floating. The main layers of the Earth are organized in the same way. Depending on whether they're divided up by how they squish around or what they're made of, geologists give different names to the different layers of the Earth. So that's how it is now. But to really understand why the Earth is organized the way it is, we need to go back to before our planet even existed. In the very young universe, hydrogen and helium were pretty much the only elements around. They condensed into stars, began the process of nuclear fusion, and eventually died, spitting heavier elements from carbon and oxygen to things like nickel and gold back out into the universe. One of those heavy elements, iron, is the most stable element produced outside of a supernova, and the early universe produced a lot of iron. That'll be important in a second. Fresh hydrogen and helium went on to form new stars like our sun, and the heavier elements collided to form the dust and debris that would become our solar system's planets and moons and asteroids and everything else. High temperatures in the early inner solar system meant that light volatile elements could only condense further out, which is why the 4 inner planets of our solar system are dense and rocky, while outer gas giants like Saturn could hypothetically float in a really big swimming pool. After proto-Earth grew larger, radioactivity, gravity, and violent boom booms melted that messy mixture of rocks and minerals, and this is where things started to get organized. Just like that tower of density, the heaviest materials like iron and nickel worked their way to the core. The lighter materials like aluminum and silicon stayed near the surface. The inner core experiences pressures more than 3 million times what we do on Earth's surface, which means that despite being as hot as the surface of the sun, the iron in our planet's inner sphere is likely solid and not liquid. The outer core is most likely liquid because it's hot, but not under as much pressure as the inner core. We know that's the case because of earthquakes appear on the surface. As certain kinds of seismic waves travel through the Earth, the liquid outer core either refracts them or blocks them altogether. And that creates seismic shadows on the opposite side of the planet. If you want to use pressure to melt metal at home, just stack up 16 million pennies. The one on the bottom should liquefy in no time. Mercury is so close to the sun that its atmosphere has long since blown away. But luckily for you and me, our liquid metal outer core lets us have an atmosphere. Deep metallic convection currents create a magnetic field that shields Earth from the solar wind. Otherwise, we'd be pounded with deadly radiation, our atmosphere would be blown away, and Earth really wouldn't be a very lifey place. Over time, Earth continues to cool, so more and more of its liquid outer core is turning solid, and we're shrinking little by little. Every earthquake that we feel is Earth taking one step closer to cooling off and becoming a real third rock from the sun. So there you have it. Like Carl Sagan said, we are star stuff who has taken its density into its own hands. It's density, right?
I'm your density.
Stay curious. People have been looking at clouds since people have been people. Those billowing shapes might have been our first art or the characters in our first stories. And we still love to pick out shapes like bears, fish, flying saucers, faces, elephants. Some clouds even fly through the sky like airplanes.
You're simply the